Okay, guys, today we are going to talk about science, just kind of a general introduction into what science is. So, what is science? What pops into your head when you think of science? So, the definition of science is the method for studying the natural world, so the world around us. When we study that, that is science. It's a process based on inquiry that helps develop explanations about events in nature. So, when we inquire something, right, we have a question and we're wanting to figure out the answer to that. When we do that, and that leads to developing explanations about events in nature, that is science. Scientists ask questions and make observations to learn about the rules that govern the natural world. So, for all intents and purposes, while you're in my classroom, each one of you are scientists. You're going to be asking questions and you're going to be making observations to help you learn and others learn about the rules that govern the natural world. So, there are three major categories of science. The first one is life science, and that deals with living things. The second one is earth science, and that investigates Earth and space. And then the third is physical science, and that studies matter and energy. So, biology specifically is life science, that falls under the life science category. Biology is the study of life. So, you are going to learn more about life science this year with me. So over time, science changes, right? Science, as we have access to more technology, as more experiments are done, science changes. So as more is learned, earlier scientific explanations might be found to be incomplete, or new technology might provide more accurate answers, thus leading to modifications of these explanations. So let's take the atomic model, for example, the atom, and that's what these three pictures are. So the one furthest to the left, that is Thomson's atom. And in the early 1900s, the British physicist J.J. Thomson created a model of the atom that consisted of electrons embedded in a ball of positive charge. Several years later, moving to the middle picture now, several years later, Ernest Rutherford created a model of the atom based on new research. And his model was different from Thomson's model. Instead of a solid ball, the atom consisted of a nucleus with electrons orbiting it like planets orbit the sun. So you can see there in the middle, that is the nucleus, and then those little blue balls around the nucleus are the electrons orbiting it. So finally, later in the 20th century, and the one furthest to the right, that's kind of the one that we have now, scientists discovered the nucleus is not a solid ball, but is made up of protons and neutrons. So if you can see, there's two different colored balls there in the middle. One is protons and one is neutrons. This improved our understanding of the atom and its behavior. So the present day model of the atom is a nucleus made of protons and neutrons surrounded by an electron cloud. The electron cloud represents the space containing rapidly moving electrons. So, starting from the furthest over to the left, once again, we have this huge positive charge with electrons just embedded into that positive charge. So that was our earliest. Well, as more was learned, we moved here to Rutherford's atom. And here he says we have a single nucleus in the center, and then we have these electrons orbiting the nucleus like planets orbit the sun. But now, present day, and this could change once again as more is learned, but present day, this is the model that we deal with. And it's known as an electron cloud model because this really does look like a cloud. But What's different is that in the middle here, yes, we still have the nucleus, but the nucleus is made up of protons and neutrons. And it's surrounded by this electron cloud. So we don't have these electrons orbiting like we thought, but we have this large electron cloud where they are just rapidly moving throughout that space. So as you can see, over time, science changes. But the things that lead to these changes in science are investigations. So investigations are how scientists learn new information about the natural world. Some investigations involved simply observing something that occurs and recording the observations, while others involve setting up an experiment with a control to test the effect of one thing on another. Sometimes investigations require us to use models. For example, when you're building a car, you have to first build a model of a car to kind of do crash courses with. The same is true with certain aspects of scientific investigations. So scientists don't just use one investigation to determine something to be scientific, to be factual. They use information from several types of investigations when attempting to learn about the natural world. And as we go through, even this week, there will be some investigations that you do simply by observing and recording your observations. And there will be other investigations where you have to set up an experiment with a control to test the effect of one thing on another. And if you notice here, there's some vocabulary words that you did yesterday. It's really important that you get those finished. It'll just help you familiarize yourself with the content. But when we're dealing with setting up an experiment, you have to have a control that you can test what you're actually wanting to find out against. So the control would be something that you have not done anything to, and you're comparing that to something that you have manipulated in some sort, which we will cover that later on in this week, but just be familiarizing yourself with some of the terms and some of the vocabulary that was assigned to you yesterday.